Assalamualaikum, a very good day, everyone. Today we will present about the Hayes Substation fire in London. Okay, next slide this is my groupmate. My name is Shifa Damia, and we'll continue with Christina, then Devon Rush, then the next one is Pretty. I will explain about the description about the fault scenario. It began, a large fire broke out at the Hayes Substation in London. The victim died that it was reported by 11:15 p.m. at 20 March 2025. The location was at the North Hayes Substation, operated by National Grid in Hayes, West London, near Heathrow Airport. How it happened? It because a transformer containing insulating oil was fully alight, creating a significant hazard due to being within a substation containing high voltage equipment. The videos that from the media show clearly some of the large power substation ablaze at the 27.5 kV substation. The situation forced more than 100 people to evacuate from near the scenes. The London Fire Brigade said that 10 fire engines and 70 firefighters were on the scene on the Nassau Avenue in Hayes. Now, we will examine how we analyze what went wrong using systematic root cause analysis. We break into the three levels, which is primary cause, contributing factor, then early sign. For the primary cause, it begins with the immediate technical failure, and the contributing factor is underlying condition that make more likely. An early sign is warning indicators that might have been detected beforehand. The official investigation confirmed that primary cause was an electricity fault within the oil field transformer. The police investigation ruled out any suspicious activity, and this was a technical failure and not a sabotage. The point for early sign, the modern electrical system have sophisticated monitoring to detect problem before the catastrophic failure occurs. Key indicators include temperature rise, abnormal dissolved gas in the insulating oil, partial discharge activities, and change in electrical characteristics. These monitoring systems are designed to provide maintaining teams with an advanced warning. The key challenges is this warning require proper interpretation and timely actions. Sometimes the progression from warning signs to failure can be very rapid. Let me show you the extent of damage across the substation infrastructure. The fire didn't just affect one component, it created cascaded of failure of some multiple systems. The main is 132 kV power transformer was severely damaged. This was the epicenter of the fire. However, the smoke and thermal stress also affect adjacent 132 kV gas insulate switchgear components, which are critical for controlling power flow. Additionally, some protective relay and control circuit was temporarily disrupted. This demonstrates how fire in the electrical substation can quickly beyond the initial failure point, affecting interconnect system that is essential for a safe operation. The next is the fault detection and diagnosis. How it was detected. Understand how this was initially detected is crucial for learning how to improve our detection system. The fault was detected when the protection relay identifies abnormal condition, specifically for overcurrent and earth fault sign. These protection systems are designed to automatically open corresponding circuit when dangerous conditions are detected, which is exactly what happened. However, this raises important question about whether early sign might have been missed, and how we can improve our diagnosis capabilities to catch problems before they become catastrophic. The fault detection process significant challenges that complicated the initial response and investigation. First, the thick smoke resulting damage hindered maintenance crew from swiftly evaluating the situation. When you have an oil-fed fire producing dense, toxic smoke, it becomes extremely difficult for personnel to safely assess the extent of the damage. Second, the initial signs were ambiguous, indicating both internal fault within the transformer and cyclical impact from surrounding components, then make it difficult to immediately pinpoint to the to the root cause and develop an appropriate response strategy. These demonstrations highlight why modern substations need to improve how monitoring and assessment capability.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Christina binti Mama Izzuddin, and I will be discussing the safety implications of the recent incident at the substation. So, the fire creates significant risk not just for personnel on site but also for emergency responders. The high voltage equipment, explosion risk, and toxic smoke were major concerns. The fire also affected public safety, with the blackout impacting traffic system and critical services in the area. For the next slide, fortunately, no fatalities or injuries were reported during this incident. However, both workers and emergency staff were at significant risk due to the nature of the fire. The quick thinking, proper training, and swift evacuation protocols in place likely prevented casualties and minimized harm. While the substation was equipped with the standard safety protocols such as circuit breakers, fire extinguishers, and emergency cut-offs, these were insufficient to completely contain the fire. A critical gap was the lack of an automated fire suppression system, which could have reduced the fire's intensity. Furthermore, there was a potential delay in relay tripping, which contributed to the escalation of the incident. From this incident, several key lessons were learned. First, the importance of an automated fire suppression system became evident. Additionally, we need to integrate advanced fault detection analytics to help identify and mitigate risk faster. Emergency coordination with fire departments should also be improved, and continued condition monitoring will help prevent similar incidents in the future.
Hello, my name is Devendra, son of Sevuru. Now I am going to present about the legal and regulatory compliance. What are the relevant laws and standards? The first of all, the Electricity Safety, Quality and Continuity Regulation 2002, which mandates safe construction and operation of electrical system with a focus on fire prevention and public safety. Secondly is a health and safety at work at 1974 requires employers including utilities company to ensure the safety of workers and the public. The Electrical City at Work Regulation 1986 is government the safe use of maintenance of electrical equipments. BSEN 61936-1 and IEC 61936-1 is a provide guidelines for high voltage installation and substation design, particularly on fire containment and maintenance and protective systems. The UK Fire Safety Order 2005 applies if fire risks are not mitigated in commercial or infrastructure settings. However, it seems there was regulatory non-compliance. Investigation by Ofgem and the health and safety executives focused on whether UK power networks failed to maintain the thermal of arc flash detection system, or upgrading engine cables and protection relays, or keeping maintenance record properly. There was early sign of infrastructure failure like aging components and slowly relay response, which suggests violation of ESQCR. For legal consequences, at the time of reporting, no fines had been issued yet, and the civil lawsuits were expected due to losses suffered by commuters and businesses. If gross negligence is proven, criminal or corporate penalties could follow. The insurance claim could also reach millions of pounds. Could adherence have prevented? Yes, as a several preventative action may have avoided or minimize the fires. A routine thermal image and conditioning monitoring of critical components may have flagged overheat or insulation degradations. A modern microprocessor based on protective relay with arc flash and temperature sensing capabilities could have tripped the affected circuit faster. The better maintenance logs, especially for underground cables joints, the transformer oil level, would have enabled earlier interventions. Fire supervision systems in older substations are often outdated. Ensure the compliance with a newer standard will reduce the fire risks. This incident may prompt Ofgem and Department of Business, Energy and Industry Strategies. They mandate the real-time digital monitoring system for substances and handling high carbon loads, and required predictive AI-based fall detection system integrate with SCADA. To introduce the stricter documentations, audits for maintenance activities in densely populated zones. Update substation fire safety protocol into include automatic shutdowns and containment systems. For my personal reflection, as a future engineer, these incidents teach me the critical importance of preventive maintenance and legal accountability. The following laws is not just about the avoiding punishment, it's about the protecting lives and infrastructure and the trust in our power system. And I have learned that technical knowledge must allow to go hand in hand with the safety values and legal responsibility to truly serve societies. Thank you.
Thank you for passing to me. My name is Preeti. My metric number is B0822100504, and I'll be presenting on societal and cultural considerations of the Hayes substation fire that occurred on March 28, 2025 in London. This incident had a significant impact on local community. Over 38,000 customers lost electricity, affecting home, businesses, and public transport systems. Train services at Paddington Station were disrupted, leading to delays that stranded thousands of commuters. Many small businesses suffered economic losses due to downtime, especially those reliant on electricity for daily operations. Some hospitals and schools had to rely on backup power, adding further stress. Understandably, public confidence in the reliability of infrastructure was shaken, especially in a developed urban area like London. Were there societal or cultural factors that influenced the response to the incident? Yes. High public expectations in the UK for uninterrupted power supply and transparent crisis communication increased pressure on the utility company. Next, the digital culture in London meant that social media played a major role in shaping narratives by spreading updates and wrong informations which amplified complaints. Next, there was a strong sense of community in some areas, with neighbors helping each other during the blackout, especially elderly and vulnerable individuals. Emergency services culture in the UK is well organized, and the London Fire Brigade responded quickly by helping to prevent the fire from spreading more. Next up, we'll talk about what ethical responsibilities did these involved parties have, and were these upheld. The electricity provider and infrastructure operator had several ethical duties, such as preventive maintenance of high-risk equipment to avoid such catastrophic failures, rapid emergency response coordination to minimize danger to public and workers, and clear and timely communication with the public and local authorities. But these are only partially upheld. While emergency responders did their part effectively, delayed public communication and possible lack of real-timing monitoring systems indicate that the utility may have fallen short in its ethical duty to prevent harm and keep the public informed. Did the incident lead to any public backlash or demand for reforms? Social media backlash with hashtags and posts criticizing the operator for poor infrastructure and communications, and calls from MPs and local leaders where they demanded investigations and compensations for affected parties and transparency in incident handling, and finally pressure from Ofgem, UK energy regulator company, to tighten fire safety regulations and ensure utilities invest in modern predictive systems. Lastly, I will talk about how did this incident shape future practices or awareness in the community or industry. The fire acted as a wake-up call. After the incident, there was much more focus on modernizing the power grid, using predictive maintenance and improving fire detection systems in substations. Communities became more aware of how fragile the infrastructure can be. Utilities also started publishing more public safety commitments and sharing updates about the system upgrades. It's clear that this event pushed both the industry and the public to think more seriously about safety and resilience.